So now we're going to be talking about degree and behavior and zeros. You can tell whether your graph is going to have an even or an odd degree based on looking at the ends of the graph. So if the ends open in the same direction, then it's an even degree. If they open in opposite directions, then it's an odd degree. So for example, if you look at the first graph here, the ends are both opening in the same direction. They're both going up, which makes this an even degree. Again, because they're both going in the same direction. And this is actually the graph for x squared, and you can tell from there that the 2 is even. This graph, the ends open in opposite directions. This side's going down, this side's going up. Since they're opposite, that makes it an odd degree. Again, this is a graph for x cubed, and 3 is an odd number. Now, even without knowing what it's the graph of, you should know if it's even or odd. If they're opening the same direction, even, opposite directions, it's odd. End behavior tells you what each end of the graph is doing. So your left side and your right side. Here, there's a specific notation that we're going to be writing these in. So when you're talking about the left side of your graph, on the left side of your graph, the x's are negative. So this is approaching negative infinity for the x. Again, I'm talking about my left side of the graph here. So when you're describing your left side, you would say as x approaches negative infinity. So this little arrow means approaches. And then you would say f of x approaches. And when you're talking about f of x, you're actually saying what your graph is doing. So when you're talking about f of x, remember that means y. So y is either going up or down. If you look at your y-axis, the lower part's negative, so that would be going towards negative infinity. The upper part's positive, so going towards positive infinity. So since the left side is going up, our y's are going towards positive infinity. So here, when I'm saying x approaches negative infinity, I'm talking about the left side. And then since on the left side, our graph's going up, our f of x is approaching positive infinity. Now, when you're talking about end behavior, you also want to discuss your right side. On the right, your x's are always positive, so they're going towards positive infinity. So I'm going to say as x approaches positive infinity, here I'm talking about the right side of my graph, f of x approaches, and if you look at that endpoint, it's going up, so that means our y's are going towards positive infinity as well. So our first statement, again, is talking about the left side of the graph. Our last statement was talking about the right side. You don't have to do it in that order, but I usually do. So if you look at the next example, we're going to do the same thing. I'm going to start by talking about my left side. So just label these real quick. So on the left side, x approaches negative infinity always. And on the left side, our graph is going down. So since it's going down, our f of x or y's are also going towards negative infinity. Now I'm going to talk about the right side. Remember, on your right side of your graph, the x's are always positive. So I'm going to say as x approaches positive infinity, and then on the right side, since that endpoint is going up, f of x or my y's are positive. So they're going towards positive infinity. So this first statement was talking about the left. It's saying that on the left, your graph is going down. Here it's talking about the right. And on the right, since it's positive infinity here, that means our graph is going up.